So if we have the following example, this is kind of worded how it would be on an AP, like multiple choice question. It would say, if f of 4 equals 2, and f prime of 4 equals 3 halves, and g of x is the inverse function to f of x, find the equation of the tangent line to g of x at x equals 2. So again, if you're trying to find it, that's like saying we want to know g of 2, and we want to know g prime of 2, where g of 2 and g prime of 2 represent the inverse of f at 2. So g of 2, or f inverse of 2, is like when f of blank equals 2. So that means that g of 2 is equal to 4. So g prime of 2, or f inverse prime of 2, according to our formula, is 1 over f prime of 4. Since g of 2 is equal to 4, so it's the derivative. So therefore, this is equal to 1 over 3 halves. So therefore, 2/3. That 2/3 represents the slope of the tangent line to g of x. 4 is my y2. 2 is my x. So the equation of my tangent line is y minus 4 equals 2/3 x minus 2. Suppose that the tangent line to y equals g of x at the point -3, 5 also passes through the point 2, -4. Find g of -3, g prime of -3, and the equation line of the tangent to y equals g of x at -3, 5. So not necessarily an inverse, but again, just kind of going back, reviewing, and reiterating those concepts. So g of -3 would be equal to what? Exactly. And g prime of -3 is equal to the derivative. So derivative represents slope. So g prime of -3 will be the slope given our 2 points. So -4 minus 5 over 2 minus a minus 3, or -9/5. And then that again represents the slope. So our equation using our point is y minus 5 equals -9/5 x minus a minus 3. So it's x plus 3. It is. You're exactly right. And it's like confusing because you see it and it's in the derivative inverse unit, so you automatically want to think of inverses, but yet not an inverse was needed at all.
You know that there can be so much more to be done than just looking at taking the y-back coordinate and doing slope.
Precisely. Okay. Let g of x equal the following function. Let h represent the inverse of g. Find h prime of 3. So again, if h is the inverse of g, that 3 is like the y value of g. So we need to set 3 equal to x cubed plus x plus 1. So our p divides q's are 1s and 2s. So I'll start with 1. 1 cubed plus 1 is 2. 2 minus 2 is 0. So my x value is 1. So therefore, h prime of 3 is equal to 1 over g prime of 1. So that means I need g prime and g prime of 1. So h prime of 3 is equal to 1/4. Feeling better?
I like those questions.
You know who doesn't like those questions?
Doesn't it?
Yes. All right. The back is some multiple choice questions exactly like they were from an AP exam. So these, I forget if I took these from like a textbook or an AP book, but like these were derivative of inverse function questions involving AP. So it says the function of f of x equals x to the fifth plus 3x minus 2 passes through the point 1, 2. If f inverse is denoted by f to the negative 1 and represents the inverse of f, find f inverse prime of 2. So again, that 2 represents the y value of the original. So we need to find the x value that makes that 0, which again ends up becoming 1.
Well, can we just take the x value in the point?
Oh yeah, I made that hard.
Yeah, I was going to say, if mine would work is
Yep.
inverse over dx at 2 equals 1 over f prime of 1.
Do you have B?
So we can just take that point.
Yep. That was just my bad. I was on such like a habit form that like I didn't even pay attention. F of 2 equals 3, f prime of 2 equals 4, g of x at x equals 3. So again, that is the y value of the original. So if we're trying to find g prime of 3, that's equal to 1 over f prime of 2. So that's equal to 1/4. So then the equation of the tangent line is y minus 2 1/4 x minus 3, because we're trying to find the equation on the tangent line of G, so you have to make sure you flip-flop your points from up here, making that my y and that my x for G. So letter D. If f of x and g of x are represented by the following, then g prime of 10 could be which of the following? Yeah. Are we okay with those two? Okay. The first page represents the inverse derivatives on the unit circle. So like arc cosine of 1/2 is kind of saying, okay, the cosine of theta equals 1/2. So what trig value gives the exactly? And remember, these are the ones that have to come from the certain quadrants. So we're only giving one answer now because they're coming from quadrants 2, 1, and 4. Okay? I just want to do one of the triangle pictures with you. So the triangle ones are SOHCAHTOAs. So it says you have the cosine of the arc sine of -3/5. That arc sine of -3/5 is kind of like saying the sine of theta. equals negative 3/5. So the sine of the arc sine makes this like the cosine of theta. And we want to know what that's equal to, given that the sine of theta is negative 3/5. So in terms of a picture, there's my theta. If the sine of theta is negative 3/5, then the opposite is negative 3. My hypotenuse is 5. If you go back to Pythagorean triples, this is a 3, 4, exactly, 5 triangle. So cosine is adjacent over hypotenuse. So the cosine of theta, bless you, is 4/5. So like the answer to the cosine sine inverse of negative 3/5 is 4/5. Does that make sense? So again, like here, you would draw your triangle. Tangent is opposite over adjacent. So you'd have your 12 and your 5. And 12 squared, 144. Actually, I think it's 13. 5, 12, 13. Yes, it is. That's a Pythagorean triple. And then sine of theta is opposite over hypotenuse. So your answer is just 12/13.